Welcome. We are Omnical. Meet the team. Project description. Omnical is a powerful day planning academic scheduling system designed with students and lecturers in mind. Here we have object-oriented analysis. Refining the use case. Below is a list of use cases that Omnical makes use of. Here we have the refined use case list. This is a selection of the potential objects. Here we have our proposed objects. This is our association matrix. This is our generalization and specialization relationship, aggregation relationships, composition relationships. Here we have our class diagram. This is our activity diagram. System design.
This is our analysis versus design. Here we have system design versus system analysis. We start with scope definition, problem analysis, then there's requirement analysis, local design, and decision analysis. And then here is our physical design, which utilizes a model-driven approach, which is comprised of modern structured design, information engineering, prototyping, and object-oriented programming. Our 12-point plan includes adding a registration process, a home screen, and an update admin info option.
Application architecture and process modeling. Application architecture. Here we have the structured diagram.
This is our file server architecture. Here's our client server architecture.
This is our data distribution diagram.
Process modeling. This is our logical data flow diagram. Physical data flows. The following diagram presents Omnical's physical data flow. The following diagram represents Omnical's physical data flow with a person or machine boundary line.
Here we have a manual design unit. Database design.
Logical data model. This is our logical data model that contains 13 tables. Database schema. In our database schema, we use the normal form. Database architecture. Here is our database architecture. Capacity planning. This is step 1 of database capacity planning. In this slide, we show that we anticipate the database capacity to be 2.3 gigabytes. Here is our database management system architecture.
Output design. Output taxonomy. Here we have the taxonomy for computer-generated outputs.
Output design. Omnical has followed and applied the following output guidelines.
Input design. Input taxonomy. Here we have our taxonomy for computer-generated inputs. Transition diagram. This diagram represents our transition diagram.
Input design. Omnical has followed and applied the following input guidelines. Dialog chart. Omnical has 5 dialog charts split between 10 forms as indicated below.
Object-oriented design.
Refining the UC model. Here is our use case list that our system makes use of. Below is a list of use cases that have been refined for our system. Below is a use case diagram which reflects the interaction of our system. Below is a use case diagram which reflects the depends on, extends, and includes interaction of our system. Modeling class interactions, behaviors, and supporting states. Step 1. Identify and clarify use case design classes. Step 2. Identify class attributes. Step 3. Identify class behaviors and responsibilities. Below is a sequence diagram of our system. Step 4. Model object states. Below is a state chart diagram of our system, updating the object model. Below is a partial design class diagram of our system's use cases. Design patterns. Adapter pattern, organizational pattern, and strategy pattern.
System implementation and construction. Implementation phase. Omnical system test results are laid out below. Furthermore, we have test data for our system test that has been conducted. Here we have the results of the system test. Here we prepare our conversion plan. Below that we have the databases that we have installed. Train users, we do through our help file, convert to new system. This is where we coded the entire system. The construction phase. Build and test networks. Omnical makes use of one database created in MySQL. Here we have the install and test new software. Here we write and test new program.
System operations support. Here we show the checklist that shows the implementation of system operations support.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.